Hi everyone, and welcome to this first Nordic Serverless live stream. My name is Gunnar Grosch, and I'll be your host for tonight. On the agenda tonight, we have two talks. First off, we'll have Stockholm's Gustav Lidén talking to us around Amazon QLDB. Gustav is solution architect at Amazon Web Services in the Nordics. And then after that, we'll have Moheeb Zara. He's a senior developer advocate for Amazon Web Services, and he'll talk to us around the serverless robotics project that he has been working on. So welcome everyone to this live stream. This is our first run with the live stream on YouTube, so hopefully everything will work as planned. But I will now leave it over to Gustav, and we'll go into Amazon QLDB with him. So just a second.
All right. So thanks, Gunnar. Hi, everyone. My name is Gustav. I am solutions architect based out of Stockholm, Sweden, and working with customers in primarily Sweden and Norway. And very glad to be here today to talk about QLDB. QLDB was introduced, more than a year ago now. It's still in early stages to be a AWS or Amazon service, but has some interesting attributes for being a database that I'd like to present to you tonight. And hopefully you'll find this interesting. So QLDB, just to give a bit of context first, just starting by the name Quantum Ledger Database. QL is for Quantum Ledger, which kind of leads your thoughts into blockchain, perhaps. Blockchain normally has, or like normally when you talk about blockchain, you often think about three parts. You have the immutable append-only ledger. You have the you have the decentralized business context where you want to achieve trust in a distributed system or with distributed actors without having a central authority. And then you create smart contracts and other types of consensus algorithms on top of the two former. So QLDB, is that blockchain, or does QLDB fit? How does that fit into this? Well, there are some fundamental differences between QLDB and the traditional blockchain setups, and I would say the most prominent difference is that where traditional blockchain setup is decentralized, QLDB focuses on use cases where you have a single and trusted authority. So a situation where the business really has the trust in towards a central authority, but wants to achieve wants to have all the nice aspects of having an immutable transaction log attached. And by having this combination of a single authority and the log, creates a situation where actually that log can be much faster and require less energy, etc., compared to centralized situations. So that's basically what AWS and Amazon saw, and this is something that has been used internally at Amazon for a fairly long time. But it was decided to make this a public service, and it now fits into the fairly large array or set of options for different database types that AWS provide. And this has been really valuable to different types of customers. Primarily, the fields that have been mostly interested in this from start have been, for example, finance, healthcare, governmental authorities, etc., where that situation is the like the status quo of having a centralized authority which you trust. All right, so given that we now have a ledger database, what is really the difference compared to all the other database options that are available today? So at the core of this difference is the transaction log. This slide shows how you can or how you normally think of transaction logs within traditional relational databases, where you basically write to the database that writes something to a table, and after that there is a transaction log produced, and that's often for replication purposes, etc. But the log itself is not really something that is it's an internal feature of the database. It's not something that is you're able to access as a user of the database. And here's where QLDB really differs, because QLDB moves that log to the center, to the core of the database. And it calls it a journal, but it is really an append-only transaction log. And that journal is like put in the center of the database and will now handle a lot of the concurrency, transaction handling functionality that you typically associate with a database. And that's where all of the action in the database goes first, and after that there will, so to say, be the traditional tables that you expect from a database, but in a couple of different versions that I will talk more about later on here. So as you work with QLDB, whenever you do a write, let's see if I can just get my pointer working here. So whenever you have an application that is working towards QLDB as a client, any writes, that will be inserts, updates, or deletes, are routed down to the journal first. So written into the journal, appended to the journal, and after that, the tables that you typically think about when you work with a database is something that are created more or less as materialized views on top. And I guess the top one here, the user or the current view, is what you normally think about as the table that you're querying. But in fact, QLDB also provides a history view of all the changes that has been going on to the data. Since data is never removed in this journal, it's always appended to. So to describe QLDB a bit further, we like to just point out some different like high-level attributes of QLDB. First one, when working with it, you probably come to think about transaction and transaction isolation. For QLDB, there is it's a simple choice. There is only one choice, and that's the highest serializable level usually available for databases, called serializable. But that isolation level basically means that you will never see any phantom reads or any artifacts that you can sometimes otherwise see in databases if you are using like lower level isolation. QLDB is a serverless service, so I guess I don't really, with this audience, I don't really need to go into what that means. But I guess you could say that when working with QLDB, you work with the concept of ledgers. So what you create with the API or using the console is a ledger. The ledger is then instantiated in the region of choice, and using all of three of the availability zones, providing a high availability setup, and also making sure to store whatever data you want to store in in multiple copies, so that you achieve a really strong durability. So you can rest assured that the data has a very, very low probability of it disappearing. So also, I could say, given here on the serverless part, in terms of what you provision in terms of capacity is basically nothing. You can also rest assured that the ledger will scale to a capacity according to your needs. That I know that the service team is currently working on dialing that capacity up, and so moving forward, it's designed from the start, and it will be able to handle massive amounts of transactions. So that shouldn't be an issue, really. So just to go back to the immutable part of the journal, this basically means that the journal will never be changed. It will only be appended to. So as you traditionally work with a database, you insert, you update, you do deletes. All of these actions that could, in a traditional database, actually mean that you are rewriting data and not having that data anymore, or having the history. That will not happen with QLDB. Every entry or every action taken on the database is just logged and added onto in this journal. There's no way really to access or to change or alter this committed data. There's basically no way to do this, and as we also see later, if you were to do that, that would break the verifiability aspects of the database. So the verifiability aspect is basically this: that you can have a cryptographic verification of the data that has been entered, and the entire log of events that has happened to the database. When you commit a transaction with QLDB, the statements that you have issued, the data that you have worked with, and metadata related to this transaction, for example, IDs and timestamps, etc., are all grouped together, and to create a hash of all of this data. And that's the SHA-256 digest. The source data for this digest also includes the hash of the previous entry of the previous entry in the journal. So this effectively links all the data together in a way that makes it impossible to change anything in this journal without this cryptographic chain of hashes breaking. We're gonna talk some more about QLDB now, and I'm gonna show you some hands-on how you typically work with QLDB. And then in the end, we're also going to look a bit more into this cryptographic verification, since this is probably interesting. It's a fairly special feature for this database. So, sorry, excuse me, here we go. So in summary, QLDB has these different properties: immutability, being verifiable cryptographically, a serverless offering, highly scalable, easy to use. We'll look at that coming up here. High isolation on the transactions, and really putting the journal into the core of the database. And this set of features really was not existent, or there is no other alternative today on the market which does all of this. And so that's basically why we introduced QLDB. As I mentioned before, the same technology, this is proven technology, so this has been used within Amazon for years earlier in providing the infrastructure services that we have, but it's not been externalized in the way that QLDB was until now. So how do you interact and how do you work with QLDB? And I'm going to show you a small demo coming up here, but just before that, I just wanted to talk or introduce two concepts or two technologies that are very much related to interacting with QLDB. And so that's number one is PartiQL, and that is the query language you used with QLDB. And the other technology is Amazon Ion, which is basically the data format that QLDB uses to store data, and which you will interact with when you write queries towards the database. So starting with PartiQL, it has been designed. These technologies might sound they're the new concepts or new names at least, but I think a lot of it is familiar. And starting with PartiQL, it really draws on everyone's more or less familiarity with SQL. So it's been designed it is like SQL compatible. You will instantly recognize what it looks like, but it has some features or differences compared to traditional SQL. And one of the most notable ones is that it is designed to be able to handle nested data. So you can work with document-style data and query that type of data using PartiQL, which is not really available or possible to do with traditional SQL. Other aspects of PartiQL is that it's really been designed to be independent of whichever data formats it uses. Now, with QLDB, it's used in combination with Ion, but that's not like an inherent coupling. And it's also been designed to not be tied to any specific data store. So while QLDB supports PartiQL, it can very well be supported by other data stores also. And I think that might be something that we will see in the future. To give you just a first look at how this looks, here is an example with some input data. Given the document to the left here, you can write a query as the one to the top right, where you basically do a select for a vehicle identification number from a registration, which is what we have to the left, and where the city is Seattle. And running this query, you will get the specific VIN of this record, which is on the top here. So this looks very straightforward and very much like SQL, and that's the intent basically. But what you can also do with PartiQL is to look into or like dig into the hierarchical structure of this document. So here's another query, for example, where you are selecting the vehicle identification number and also a person by working into this document the owners of the vehicle registration and the secondary owners of the owner. So you see here that the owners contains a primary and secondary owner, and this query is actually looking for secondary owners with this specific ID. It's finding one here and returning this output. So I'm going to be doing some demoing using PartiQL moving forward, so we'll come back to that. Next was Ion, and this is the data format that QLDB supports. And it's perhaps you saw this the previous example here was actually Ion. It looks a lot like JSON. If someone was very familiar with JSON and sharp-eyed, they would have seen things that are not allowed with JSON syntax. So Ion is a superset of JSON. That means basically that any JSON document is a valid Ion document, but there are constructs you can create with Ion that are not available in or possible with JSON. And it was designed as a superset, as I said, but it also has two representations. So the text format, which we just saw, but there is also a binary format or a binary representation for the same JSON document, or like another JSON document. So you have this possibility of going either with text or with binary formats. And of course, the binary format is there to allow for efficient storage, efficient transmitting, sending data, and also to work well with scanning data, for example, on disk, and being able to skip scan through data for efficient handling of large amounts of data on disk. Ion is a open source project available at GitHub, and has its specification on GitHub, and also has a specification process driven there. It has different libraries for the popular languages, and also has related projects. For example, a schema project for creating schemas for Ion. And excuse me here. So here's just a quick example of some differences between JSON and Ion, since a lot of people are very familiar with JSON. So for one, Ion comments are supported, so you can create comments within Ion documents. There is a timestamp format. This has a specific format, so that you know that this is actually a valid timestamp. And also there are three different number formats, whereas JSON has one. There is an integer format, there is a decimal format, and then there's a float format in JSON. And in Ion. JSON has null objects, and so does Ion, but those null objects are also typed, so you can distinguish between the null of a string or a null of an integer, for example. And these extensions have largely been created to be able to reduce the amount of interpretation that you need to do with JSON documents. And it's been designed to be able to survive moving between several generations of software, or as software evolves, the data stays more at rest, or changes less quickly, and this has been the intent there is for it to be able to survive long between systems. All right, to give just a quick mapping between relational databases and QLDB, since relational is something very many are familiar with. Going from the top here, we have the database, which has the ledger equivalent in QLDB. Both relational and QLDB have tables. So in the same way as you create tables in relational, you create tables in QLDB. You create indexes in the same way. But whereas in relational you have rows of data, with QLDB you have documents. So the documents being Ion documents. And where you have columns within the rows in relational, it basically comes down to the equivalent is document attributes. Interacting, you have the SQL equivalent is PartiQL, which looks a lot like it, but is a bit different, because you are able to query the hierarchy of the documents. Lastly, audit logs have the equivalent in QLDB of journals. But I would say also wanting to point out that it's very different, because the journal has been moved to the core of the database in QLDB, whereas audit logs and transaction logs are a bit towards the, or not a feature, but not in central in the same way in relational databases. All right, so let's go here first. This is the QLDB console, and there is a fairly easy way to get started using QLDB. It has a nice entry point here. I did this yesterday just to create some demo data for today. So I did basically the two first steps here. I created a ledger, and then I introduced some sample data into that ledger. And that's what we're going to look at now. So this one. And if I go here, I will do query ledger, and this is a query interface. So here, with this interface, you're able to like test queries, to write PartiQL statements just to get familiar or work. So having chosen this ledger, we here see the different tables of that ledger. I can just click here to create the basic query of selecting everything from a specific table. So if I run that now, I will here get in as an output the different entries into this in this table right now. So here, this is now a very much a table-like structure here, and this is purely user interface, right? So the console here has converted this the documents, the ION documents in the ledger, in the table, to a table here. So this is purely UI, so to say, for ease of use. So what I can do here now is to also access data from the journal, because this is the regular user view of the table, or the application level view. But I can here, add a prefix here, like this. If I add this to the query, I will get a different result. And you will say two T's spelling. So you will notice here now that the columns that were returned are not the same anymore. And these are basically the top level attributes of the document. But now we see a block address, we see a hash, we see a data attribute, and this contains all of the data that was shown before. It also contains a metadata attribute, which contains the ID of the document, a version, a transaction time, and a transaction ID. So these are like important aspects of this data that you can now have access to. So, for example, if I now I can modify this query to look like this as small p. And I will also add something more here. IP ID. Where am I going to pick an ID here? Take this one. And so now I'm actually querying this data by the metadata. Sorry, what's wrong? Equals. Using a keyword I'm not used to. Sorry about that. So here I have the data now, and I queried it using the ID of the metadata of the journal, which is not available really if you just look at the specific person here. So this is an ID that is core to the journal, but not really available in the application data that you use. What I can also do here is I can, instead of using the committed view, I can also use the history view. So by adding this to the query, I get the previous journal structure here as before. I can see now I only have one entry here, which means that I only have inserted this data, done nothing more. But I could actually do this now. I could say that I want to update. I'm going to use a saved query here now. And I'm going to change this ID. But now I'm basically wanting to update the person entry here and set my name as first name instead. And so I've done this update now. And now if I go back and do the history view, I should get two return. A minute. I now have two entries here, so I get two results for this query where I queried by a specific ID, but the reason for that is that I have basically two versions of this document that have been recorded to QLDB, and I see here they have the same ID, but they have different versions. This one is version 0, this one is version 1, and we have different transaction times here. And I can see that the data that was changed was changing the first name here from Brent to Gustav. So these are different things that you can do with QLDB, and I just wanted to show this how this works. And in the interest of time, I'll move on now, since we also have Moheeb talking later on, so I don't want to I want to leave him time. But before leaving over, I just wanted to go back to the presentation and talk a bit about the cryptographic verifiability. So similar to what we just did in inserting and updating data, just like to walk through this hash chain or how the hashes work. So when we insert data or do any action on this database or this ledger, there is constantly hashes produced. And I didn't mention that before, but two important aspects of a hash are that, for one, hashes are, first of all, fairly simple or like not very expensive transactions, or they don't take a lot of compute. They create a fixed length digest, and if you change something or even very small in the input, it will create a large have a large effect on the output. So the hash will be very different if you just change a single character. Other really important aspect is that given that you have the hash, you have no possibility of going back to the original data. So you really use the hashes as a kind of like a rubber stamp or a identification for data built on the contents. So inserting data will create a hash. Updating data will create a new hash for the new record, and that includes the former hash. And doing this a third time, for example, with the delete, will just append a tombstone, basically saying that this data is no longer exists in the current state. So all of these hashes are constantly recorded. Now, what you can do here is extract a hash from the database. We call that digest. The digest is basically this hash value at a point in time. So if you have that, then you are able to backtrack and make sure that no changes have been made to the data. So, for example, if I don't know if everyone can see this, but there in the first insert, the first entry into this journal now, the I of Tracy, of the owner, was changed to a Y. So this small change in that input will create a totally different hash. And given that that hash is changed, had that been the original data, the hash for the second entry would have been different, and the hash for the third entry would have been different. So given that you have exported a digest from the ledger, you can compare, and if they match, basically no data has been changed. But should everything have changed, then you will be able to detect that. Now, there are additional aspects to this because you can't really handle this like doing this for all of the changes of the database. So in practice, this is done a bit differently. You create the hashes, you create the digest, you export the digest, and you could basically, well, as long as you regularly export the digest and make that available to whoever wants to verify the integrity of the data, then you create basically you create a tree of hashes for all of the hashes of all of the entries in the log. That will enable you to do a verification chain that is basically only logarithmic related to the amount of entries in the digest. So it creates a lot easier way, or a much cheaper way to verify the integrity of the data. But this is a very important aspect of QLDB, and what really sets it apart from other databases. This is something that you can do with other databases, and it enables you to mathematically prove that data has not been changed, and that I mean there's really no way that anybody, even some or three sysadmins in conspiracy at AWS, would be able to change data without that being noticed. So rounding off this presentation, I just want to note this also that right now there is a preview of another feature in QLDB called QLDB streaming. And if you are familiar with DynamoDB streaming, for example, it's fairly similar. So basically all of the events going into, or all of the transactions going into QLDB are available as a stream through Kinesis that you can use for different purposes. You might have different logic that you want to trigger based on these events. You can have analytic reasons to do this, or often also a very interesting pattern that we see evolving from the customers who've started using QLDB is to actually put some other database behind. Because while QLDB is very performant and as a transaction log and handling transactions and providing this like durable and verifiable anchor for your data, there's still differences in the ways that you can leverage PartiQL to query the data. So we see customers adding on top Elasticsearch or some relational database or Dynamo. You can really make a choice there depending on what your queries look like and how you want to handle that. But if you have query patterns that are really advanced, then that could be a good introduction or a good thing to do too. So yeah, that concludes my presentation. I think you still need to sign up for QLDB streaming if you want to use it, but we can also expect that to be coming here in the upcoming months, perhaps. So thanks a lot. We talked to Gunnar before about questions. I don't know if there have been any questions that we should take now, or we should take that after Moheeb's presentation.
Okay. Well, we have received a few questions in Slack, so we can just briefly go through them, if it's okay, Gustav?
Yeah, okay.
The first one is if there is anything to think about in regards to scaling when it comes to QLDB. You mentioned that it is a serverless service.
Yeah. No, so you don't provision capacity, neither like for infrastructure nor for like write or read capacity units in the way that you do with, for example, QLDB. So right now, no, there is no way to provision capacity, and the service is designed to not really. You should not have to do that. So it will scale according to your needs. And I know that there are like there is capacity enough for the use cases that are like running today, and this is one of the core things that the service team is working on right now or during 2020 to drastically also improve this scalability to basically be unlimited. And because the design of QLDB is basically for it to scale out very well. So just by adding more resources, you will be able to handle even larger throughput. But you should not have to worry about this.
No. Another question was, where does QLDB fit in the database lineup of services? But being a purpose-built database, it's perhaps doesn't really fit in anywhere. It's purposely built.
Yeah, so I'm just going to move back to this slide here. So I mean, this is the kind of the lineup of different purpose-built databases at AWS, and it really constitutes a new category here to the right. So the ledger database is here on the far right of this slide is currently only occupied by QLDB. Whereas, for example, relational would include RDS and Aurora, etc. So it is a kind of a new slot for all of the different purpose-built databases at AWS. Just adding to that, I mean, it has similarities to relational in terms of talking about tables, etc. But it also has, since it stores documents and not rows, it also has a lot of similarities to Dynamo. But it's conceptually something in between, but technically also totally different from both of them.
Great. Okay, Gustav, thank you very much. We're going to hand it over to Moheeb now. But if there are any more questions, you'll be answering them in the Slack as well, right?
Sure.
Cool. Thank you very much.
Thank you.
Can you hear me? All right. Hi, so my name is Moheeb Zara. I'm a senior developer advocate on the AWS Serverless team. So we go out to events, do these presentations, and write content to help out people who want to build things on serverless. My role is a little different with my background. I'm a roboticist by trade, maker, hacker. And so one thing I set out to build was a telepresence robot using serverless. The inspiration came from a web service called Remo.tv, or formerly known as Let's Robot.tv, where you can log in and control these robots from around the world. And I want to see what would it take to do this without really using a server. So I started with this. This is a STS Pi, Raspberry Pi based robot kit from Pi Moroni. And so telepresence robot is really any robot that you can remotely operate and see a video stream or be able to experience and explore an environment remotely, such as a Mars rover or robots that allow the elderly to visit their family remotely from anywhere in the world. And this is built on top of a Raspberry Pi. And the Raspberry Pi is a single board Linux computer that's open source. You may have seen these before. And on that device, there's a number of GPIO pins, meaning it can interface with physical hardware. So I thought it was a perfect spot to start. It's very popular in robotics. And so I have this blog post that's already published, and it's part 1 on how to build this robot. And so it really can be built with other frameworks or robot platforms. This is just the platform I settled on. And I'll show you a quick demo, and then we'll walk into how the magic really happens. So I'm going to create an SSH connection to the Raspberry Pi that I have sitting next to me. I'm going to put my webcam. Okay. You should be seeing a feed now of the robot. So log into it. So what I'm doing is tunneling into the Linux distribution running on the Raspberry Pi on this robot. And I've got a robot script in here. Turn that on, connect. And I've also built a web front end using Amplify. So I can log in here. There we go. And I'm going to open up a video connection. So this robot transmits video using WebRTC. So now you see a live feed coming in from it. So if I wave my hand, you should see that. And I can send it commands to move. So you can see it moving whenever I press a button, and it drives around. So now effectively, anyone can go into this website, log in, and control this robot. And that's all using serverless and AWS. Services like AWS IoT, Kinesis video streams, and Amazon Cognito. So to build that was kind of a journey in trying. I'm by no means as much a serverless expert as the rest of my colleagues. So there was a bit of a journey finding this. So to make it easy for people to be able to come into this, I decided to make a serverless application that's deployable through AWS Serverless Application Repository. This is a repository for apps built using SAM templates, which are extensions of the CloudFormation templates, the serverless application model. So the base structure of this, it creates an IoT device and creates two policies that allow this IoT device to assume a what's called a role alias, and which basically a device can connect using IoT certificate to access a role that gives it permissions to another service. In this case, Amazon Kinesis video streams, and I'll talk in a moment about why I went that route. It also gives it permissions to connect to AWS IoT Core. So there's a Python script running on this device that connects to AWS IoT using MQTT, and it runs another separate application for transmitting video. It listens in on a message topic. So AWS IoT lets you pass messages between devices and services. And I have a Lambda function that, let's pull this up here, that has an API gateway, Amazon API gateway endpoint that when posted to will invoke this Lambda function to publish to a specific topic, which is the robot name / action with a direction that was passed to it. And that'll go through IoT Core, through the MQTT protocol, and to the device. So the robot just needs to connect to AWS IoT, and then I have a serverless function that can then talk to the robot. So effectively, this robot now has an API. And so whenever I click these buttons here, that's calling that API. So what this also does, this serverless application, once deployed, produces an endpoint for the IoT credentials provider. So the Python script connects to AWS IoT using the Python SDK. But to transmit video, there's a number of different routes I could have taken. I started out by using an example script for transmitting a video directly into a Kinesis video stream, which is great for having high quality video that can be stored over a long period of time and consumed by numerous clients. But I chose to go with WebRTC because with the robot, you want as much real-time communication, real-time view as possible. But so there's a example on the AWS Labs GitHub called Amazon Kinesis Video Streams WebRTC for C, which this sample app can be run on a Linux device or any other computer, and when run with AWS credentials, an access key and a secret key, it will connect to what's called a signaling channel. So while there are Kinesis video streams, which are direct feeds, there's also WebRTC signaling channels, which allow two clients to connect and say, hey, how do I communicate directly with you? And so this example does that with video. And so I found that you could use it with just the access key credentials, but I wanted to be able to use one set of credentials on this device. So there's a way to provide it those IoT credentials and then have it use a credentials provider to then assume a role and then provide back an access key and a secret key. That's explanation here. So, right, when it uses the security keys or the private key and certificate of the IoT device, it can then authorize and get those credentials. All right, so let's walk through step by step. So first, what I'm going to do is now I'm going to wipe this robot and we're going to start a little bit fresh. Okay. Sign in here real quick. All right. So in the serverless application repository, so all you need to do to deploy the sample application is provide a robot name, and we'll give it something arbitrary. We'll call it Nordic for now, and a stack name. And this will deploy a number of resources. So let's take a look at that template. So this is the SAM template, the serverless application model template for the application that's being deployed right now. So we're creating a function. This is the send action function. This is the one that publishes to IoT. So in its policy document, I've given it the permissions to publish and to describe endpoint. That's so that it can get the address for our AWS IoT environment where it can then publish to. We create an IoT thing, and we don't attach the policies to it because when you create an AWS IoT device, you can only download its certificate and private key on creation. So we just set up the policies and the thing itself, and then we'll go and manually create the certificate later. So for the robot's permissions that it needs is the ability to connect to AWS IoT, to subscribe, publish, and receive. So, and then we give it the resources and we can template it out in this way, where we're referencing the robot name that was provided in the template in its parameters and saying give it permissions for the topic filter of whatever robot name / action for subscribing and publishing to. We then create our Kinesis video certificate-based role. So this is the assumed role that we'll connect to when we create a role alias. So a role alias is a feature in AWS IoT that lets you say, create a policy that says this alias points to this role. So when anything connects as this IoT device, you can provide them this role and the credentials necessary. So these actions it provides are give the credentials the permissions to a Kinesis video signaling channel that's created by the name of the IoT device. So when it goes to access this, it just fills with this. And you can create, this role can be assumed by multiple devices. It doesn't have to be just a single one. And to create the role alias, since that's not supported natively in CloudFormation or in SAM, I'm using a custom resource. So with the custom resource, you can create a Lambda function that actually is used on deployment to create resources that don't already exist. So for the role alias, there's just this extra serverless function that will go through and do all the steps in validation to make sure that does this role alias already exist? Do we need to create it? Do we need to update it? And we're doing the same for a couple of other custom resources. To create the signaling channel, we have another custom resource here that will create that signaling channel based on the parameters we give it. Back in. And we'll give those resources all the permissions. All right, and then to output, at the end, we do need this IoT credentials endpoint. So this is something you can pull from the AWS console, or if you have the AWS CLI, sorry. But I wanted to make this guide consumable by people who might not be familiar with using CLI tools. So instead, I just created another custom resource that provides that and simply just provides that endpoint as an output in the CloudFormation stack. So you can see here, the creation is complete. Click and view the CloudFormation stack. And see the outputs here. So we have our API URL. This is the Amazon API Gateway endpoint and the credentials endpoint. So in this deployment, there's no security on the API Gateway endpoint. The second part of this guide that's coming soon, showing the web app, walks through the process of adding an authorizer so that only authenticated users can access control of the robot. So now we have that. Next step is we create that certificate I talked about for the IoT device. So now we see the IoT thing was created. And now we create its credentials. And we activate them. Download just the certificate and the private key. And this is something that you can only do once and on creation. So now we attach the policies. We have the Nordic policy that was created for it. This is, again, the permissions to publish. And we have the role alias policy. Cool. Right. And now back on the robot, what I had done prior to this, because it takes a bit of time, is I ran this install script. So what this does is it updates all the packages on the Raspberry Pi, which runs what's called Raspbian. It's a lightweight Debian distribution specifically for this device. So it's already got a number of things included. And then we install a bunch of dependencies for building the WebRTC video producer application and the AWS IoT Python SDK. And based on what motor driver is being used. So now I use this STS Pi kit here, which uses what's called an Explorer hat. So a Raspberry Pi looks like this without all the stuff on it. So, what's on here is a camera module, which connects through a ribbon cable to the Linux board itself. And then it has these headers, and you can just plop on these modules. So in this case, I've used this specific motor driver, but there's another commonly used motor driver called the Adafruit motor hat. So, but in this case, we are installing the Python Explorer hat libraries. And it goes through, builds this web streamer app, does a quick modification to it where the base example only allows using an access key and ID in secret. Since we need to do the IoT authentication, I've just simply modified this. And this is all available on the GitHub, and I'll provide a link to that afterwards, where I've told it to use different credentials. So it builds that and then creates a directory where it drops in an empty config folder for certs, the Amazon root cert trust certificate authority required for IoT authentication, as well as the base Python script for running the robot, which just needs the IoT core endpoint, the thing name, the certificate authority, the device certificate, and the private key. So now that we've created those certificates, that certificate and that private key, I've already installed this script on the robot. We've deployed the backend serverless application. I can go in and we'll create the certs again here. And we'll create a certificate. And I have that here, I believe. So I'm just saving that with the text-based or terminal-based text editor. We needed the private key. And I'm going to re-download that root cert, I think. Let me have it. Yeah. Need to re-download that. Okay. So now we also need to adjust this config file here. So now the core endpoint and the credential endpoint, I don't need to change because they're the same on this environment. But we'll change this, the device name. Cool. Now, if I run it, it's detected its motor shield, and that's showing it's connected to WebRTC, and we're connected to AWS IoT. So I was able to first connect using the Kinesis Video WebRTC sample application using IoT credentials. It assumed a role with Kinesis Video permissions, received an access key and ID and token, used that to authenticate, and then it also created a connection to AWS IoT over MQTT. So I can go back to this CloudFormation stack, see our resources. We have this Lambda function, and I can send it dummy information to invoke this robot. Let's see. that is our endpoint. So to test, I'm just going to call it using a REST request using curl. So this is going to say post this JSON message action forward, post it to the endpoint /publish. So I'll do that on my host machine. And we just saw it move, right? So move forward again, and I can change that to go left. Cool, now this robot has an API. And walking back through that once more, in case anybody got lost, right? All we did was deploy a serverless application using SAR, the serverless application repository. So we provided it one parameter. It did all the heavy lifting, created the Kinesis video signaling channel, created our policies, created the IoT thing, created the role alias. We then created a certificate based on that role alias policy and the IoT policy. And then it also deployed an Amazon API gateway endpoint that points to a serverless function that publishes to an IoT topic that is subscribed to by the device. And what's on the device was let's go back down here. Earlier I ran an install script that created a file structure as such, which you have a main Python script that runs the video streamer, connects to IoT, and we have all of our config all in one place with all our dependencies installed. So essentially a two-step process: install two things, and then third step is provide your credentials. Now, I also showed this web app. If I wanted to connect this web app to this robot, there's another couple of things I've done here. So in this same repository, which again is on the AWS samples GitHub under AWS Serverless Telepresence Robot, I've got this Amplify app. So Amplify is, if you're not familiar, it's a framework for deploying web applications really easily. So it has built-in resources to handle all the deployment of backend resources such as authentication or an API. And so in this Amplify application, where I've ran a couple of steps. So I initialized Amplify in the project. I used Amplify add-auth to create a basic Amazon Cognito-based authentication flow. Used Amplify push to push those resources and have them deploy into the AWS cloud. And then I can add hosting and publish to give it an actual static page where I can access it. And so it's using, again, Cognito in its config. And then the endpoint I provided in its config is the send action endpoint that we just created. And we say to authenticate to that. So in order for that to be able to authenticate with a new app, I would have to go into, let's see, where are we? Our API gateway. So we go to the REST API that was deployed. Right, and we're going to create an authorizer. So again, I've already run the steps on here to create this all the authentication for the Amplify app. So create a new authorizer. We'll say it's Cognito. And its token source will be authorization. And the Cognito pool, we'll use this user pool ID. create, and then back in resources, select the endpoint. And then just add that authorization. Oh, sorry, refresh now. And so cool, now that endpoint won't be usable unless it's from an authenticated user. So that'll allow anybody to message that. However, we still need to add permissions for video so that the web app can access that. So there's a way for users to assume roles here. So here. So there's an auth role that's created by Amplify. And this is basically the role that whenever an authenticated user is logged in, they'll have access to these permissions. So I had set it for a different robot. So I'm just going to edit that policy that already exists. So again, this is saying assume that resource. So I can actually just add another resource, but I'm going to, so I'll just change that to Nordic. Again, this gives it all the permissions it needs to be able to connect to the signaling channel and get the information to connect directly to the robot stream. Cool. So, but before that, we need to then give it the new endpoint. So we had that in our outputs here. So this is just another config file used by the web app. And then we want to give it the Amazon resource name of the signaling channel. So we just copy that here. Cool. All right. So we've configured that to have its authentication. Its auth role can access the permissions to connect to the video channel. We've given it the ARN. We've also given it, created an authorizer where only authenticated users can hit that endpoint, and we've provided that here. So now if I go back here, I'm just gonna restart that app with npm run serve. This will start it up locally for me. Now it does that. So this app has two components built into it. It's a Vue app, Vue.js. And so I've created two sample components here, one for viewing a video stream, being able to open it and connect to it using authenticated credentials, as well as the ARN. So as long as that's provided, this component will display video and give a number of controls. And then another component for creating the buttons and interfaces that we'll just call this post data function, which accesses the API that we configured early on in the app. So now that's running on localhost. I'm already signed in. So make sure we run that script on the robot again. We're good. Should in a moment see video. So cool. I can drive this robot now, and it effectively only took a few minutes to deploy a whole backend and web front end for controlling a robot. So this is all out there. It's all online. Feel free to reach out to me for questions on anything like this. We'll have the second part of this coming soon, which is the full blog post on how to deploy the web app, as well as more in-depth explanation of how that all works. Again, for this robot example, you don't have to use this robot kit. I've used another platform. This is another robot I have sitting in my place, which actually has a dual stereoscopic camera. So I can, and a solar battery pack and a different motor shield. This is using the Adafruit motor shield and a tank tread platform. And I use this as a VR telepresence robot since it has a 2-camera feed. So I'll play this little video here, give you an idea. So it gives me 2 feeds, and when I run that full screen with a VR headset, because the web app can be opened on mobile, I can actually experience full 3D VR remotely. And it was the same process I did for deploying this robot that we just did. So, all right, thanks. Did we get any questions?
Hey. Well, actually, no questions. So I think everyone was impressed and understood what you were doing. But really cool. So can you once again just tell us what AWS services was involved? Cool. Yeah. And is this the first robotics project you've done using AWS services?
LiDAR system to it.
Apparently you didn't have any audio, so...
Nope.
Can you explain the AWS services once more?
Yes, of course. Yeah, so the AWS services used was Amazon API Gateway, providing an endpoint to AWS Lambda function. I used the AWS serverless application repository to deploy the application. AWS IoT for communication between the robot, and authentication for Amazon Kinesis video streams signaling channel. And then Amazon Cognito to provide authentication for the web app, which was built with AWS Amplify.
Really cool. So, if people don't have any other questions right now, then thank you very much, Moheeb, for joining us at Nordic Serverless.
Thank you for having me. Cheers.
Thanks. So, now back to Gustav. I think there was a question you wanted to answer.
Yeah, so I saw a question in the Slack on the like use cases for QLDB and related to also like implementing blockchain. And I just wanted to clarify that I mean there are the blockchain use cases, and we have the blockchain services for doing that. But this is really intended for as a service that is for other situations and specifically other business contexts and where you don't have the need for distributed trust. So you still still want the immutable ledger, you want all the nice features of cryptographic verifiability, etc. But you are basically in a business context where you are trusting a centralized authority. So typical examples are banks, for example. We have one public reference in the Nordics, which is Klarna. We're using QLDB for building their services, and other interested authorities are in hospital, Medicare, governmental agencies, and also I know of other customers like vehicle producers that want to really have a tight recording, so to say, of their production process, etc. So lots of different use cases, but they all relate to the fact that you have someone you trust who is building a service for you. So if you are looking into the traditional blockchain distributed trust, there are other services than QLDB.
Okay. Any other questions you want to respond to, Gustav? Or
no, I think that was the one that I saw that I just wanted to clarify. I realized that perhaps starting with talking about blockchain could have made that a bit unclear.
No worries. Okay, well, thank you once again, Gustav, for joining us tonight. Hope to have you as a guest speaker in future as well.
Yeah, I would be glad to come back. Thanks.
So, with that, our broadcast for tonight, our live stream comes to an end. I just want to say that we have several events coming up. They will show up on the Meetup pages shortly. We have the first one scheduled for the 15th of April. And then we'll have a special event on the 21st of April. That's an event I really think you will all enjoy quite a lot. So keep an eye out for those. Of course, we'll also post them on both Twitter and LinkedIn. And thank you all for joining us tonight. I hope you enjoyed both presentations from Gustav and from Moheeb. Well, see you soon.